this up. So I didn't get, oops, this is not week 2 though. Wait a minute here. That is week, oh no. I'll have to fix that, guys. I'll fix it while we're doing the Kahoot here. All right, so that's week 1, or not week 1, physical science 1. So let's do this real quick here. Let me get this going here. I'm going to exit this. So this is vocabulary test for tomorrow's forces test. I know you guys are going to do really well on this, but let's do one more time practicing the forces test. All right, so I'm going to have you guys do team mode on this, see how you guys do, and I'll get you started on this. Remember, you can use the vocabulary here, so I'm going to give you guys a link, and while I do that, I'll get the names for the quizzes in the right order here. I don't know why I got this backwards. Good morning, Stephen. There you guys go. Get in there, team mode. Because I want to do a drawing today, but I got the wrong names in the wrong places here. So, all right. Waiting for teams. So I will put the names in. Tomorrow will be our last drawing for the week because we have Win Day on Thursday, and then we have parent-teacher conferences on Friday. So get in there for the teams. Thanks, Grace. Oh, is it asking you to make your own name? Yeah. I don't know. So you could put team 1, just call yourself a color team, blue team, and choose PPL. All right. Red. Okay, that's cool. I just try to keep the game things seems like a long thing rather than having people watch the game thing. I do it just toward the end. See what we have here. Forces that are the same direction. Next, who's the winner here? MDR. Second place, LOL, and green. All right. Okay. So we're going to work on some assignments, and then I will have to rearrange the names for the drawing by the end of the hour. So I'll do that once I get through these notes here. So let's go. Good job, guys. Let's take a look at this assignment here. This one, what we're doing is Newton's. Let's go here. Where are you? There we go. We're talking about Newton's laws. Okay, so they get a little confusing. So let's see if we can bring that up for you guys. Okay, so Newton's laws. Okay, we have 3 of them. First law, they all describe motion. All right, so Newton's law states that an object at rest stays at rest, and in motion is constant velocity unless acted on by an unbalanced force. So we saw that in yesterday's terminal velocity. The balanced forces between drag and gravity cause the object to have an constant velocity or terminal velocity at about 120 miles an hour for falling objects, people out of the planes. So so you can have some movement, but it's for in balanced forces. So inertia, tendency of an object to remain at rest or stay in motion, proportional to its mass. So the bigger it is, the harder it is to move, right? So a stationary object with unbalanced forces will always move, will accelerate. A stationary object with balanced forces will stay still. A moving object with unbalanced forces, right, will accelerate or decelerate, slow down or speed up. A moving object with balanced forces will continue moving at the constant velocity. So as we talked about with terminal velocity yesterday. So we're going to do some problems. Newton's second law. Remember, Newton's second law talks about the influence of unbalanced forces, a net force of greater than 0. And we use that force is equal to mass times acceleration. So let's do this one together. So let me get my pen started up again here. Okay, so all right, so if we've got a force, so remember we're going to use force equals mass times acceleration. We've got the mass here, that's 20. Kilograms is the unit for mass, and the acceleration times 2 meters per second squared. So that ends up giving us a Newton of, so multiply those together, 20 times 2 gives you what? Thanks, Gabby. Let's get in there, ladies and gentlemen. Put the number in there and put an N by the end of it, okay, for the newtons. All right, so we're multiplying 2 times 20. Thanks, Dylan. Thanks, Gabby. All right, thanks, Rachel. Anybody else? Can we get in there? DeAndre, did he walk away? Did he say? Yeah, he walked away from it. Aaliyah, Blake, Carmen, DeAndre, Jordan, Journey, Kendrick, Ken, Madeline, Gray, Stephen. So we're using newtons on this one. So we got 1, 2, 3, 4, 5 people out of 17. Yeah, sometimes the multiplication parts here people don't want to attend to. So there'll be one problem on this on the force test here where and again, what's the force given to required to cause an acceleration? Okay, so so again, we've got, and this one's missing, this should say 10 kilograms. Okay, now you notice it says what's the force needed to require to cause an acceleration. So we don't have the acceleration here. Okay, so we have to find the slope of that acceleration. All right, so remember V final minus V initial, velocity final minus velocity initial divided by the time, the change in time. So this is only 1 second, so I don't have to worry about that. Velocity final is 40 minus 20 divided by 1. So this is 20 meters per second squared. And I'm going to use my 10 kilograms, 10 kilograms, 10 kilograms times 20. 10 times 20 gives me the force in newtons. So what do we got? 10 times 20, what do you get? 10 times 20. Thanks for guys. I really do appreciate you trying to get in there. I know we've got a lot of people that are not doing it, but I do appreciate you, even the few that do. Okay. I would appreciate it is expected if you're in live classes that you try to participate. So I know that you're here and not just sitting back, but also to see if there is answers that you are having trouble with, right? So 10 times 20. All right, so what's 10 times 20 in newtons? 10 times 20. All right, 10 times 20, not 10 plus 30, 10 times 20, because remember, this is force equals mass times acceleration, so 10 times 20. There you go, Rachel. Thank you much. So you should have gotten, if you're using your calculator, 10 times 20 should have give you some number in the form of newtons. So the hardest part on this one is getting the slope of the line. That'll give you the acceleration, right? So you have to do the V final minus V initial. There's like one problem on the test that looks like that. 3 people, huh? All right. 3 people is all I'm getting. Okay. All right. So probably leaving the planet today. All right. So, okay. And I know that people have all different varieties um, of education or not should say education, but math ability, right? So I'm trying to make it simple so that you can do this. So if you can assure me that you can do these problems in class, I really do appreciate that. So what's the acceleration? So what we do with acceleration here is we cover this triangle. And again, like a lot of times I have these available for you, cover the triangle and they're above each other, force divided by mass. So force divided by mass. Okay, and we're going to try this one together. I really do appreciate you guys doing this. Really helps me out, and it also helps get the data I need to see if I need to focus on helping some people here. So force is 10 newtons. So 10 divided by 5 kilograms. Okay, so you do need to know that kilograms is your mass for M, and the 10 newtons here. And you're going to get meters per second squared is your answer. All right, so 10 divided by 5, what do you get? Thanks, Kendrick. What do we get? 10 divided by 5. Use your calculator, put the 10 in there, hit the divide sign, and then hit 5 and then equal. Thanks, DeAndre. I'm glad you made it back. And this is going to be in meters per second squared. Thanks, Grace. How about you, Thomas or Stephen, Rachel, Gray, Madeline, Ken, Cassidy, Gabby, Dylan, Carmen, Blake, anybody? Adriana? All right. Well, I got one more. Thanks, Gabby. 10 divided by 5. 10 divided by 5. You had to hit the times button there. All right. So, and I got, all right. So we got, so we got 6 people out of 19. Right. And most of you got 2 meters per second squared. So again, these are the notes that you will use to help you write your notes for the test this week. So they're all in the modules. So gravity, force possessed by objects that attract other objects, makes objects fall. Not just the attraction toward the earth, because the law of universal gravitation says everything has gravity if it has mass. Objects attract each other with strength that depends on the distance between the objects and the size of the masses. So the closer you are together with somebody else, the more attractive force you will have. It's not called chemistry, it's called attractive forces, but because we don't have a lot of mass, we don't feel it. Okay. All right, so let's try this one. This is a multiple choice question. So let me show you how this one works. So calculating Newton, the dog, has a mass of 8 kilograms and jumps off the couch, and gravity has a force of 9.8 meters per second squared. Something that should be, you should understand as a number, about 10 meters per second squared is what they use. So you're going to take the force equals mass times acceleration here. So the force, the mass is going to be 8 kilograms times 9.8 meters per second squared, and you're going to get one of these answers here. So which one of this is going to be? So 8 times 9.8. So multiplying your answer, 8.9 times 9.8. Thanks, Dylan. Thanks, Rachel, Carmen. Thank you, guys. Natasia, how about you, or Gray? All right. Thank you much. I appreciate it. Carmen, thank you for getting in there. Thanks, Kylie. Thanks, Adriana. Yeah, so you guys have this answer right here, 78.4. Good job, guys. All right, so, and we talked about this yesterday, so we're running out, we're going to be stopping here in a minute. The terminal velocity of a force due to drag or air friction is the maximum and balances the falling object's weight. And terminal velocity is constant velocity. So this is really an unbalanced, is a balanced force, even though it's moving. You might not think that hurtling to the earth at 120 miles an hour is a balanced force, but because you're not speeding up faster and faster and faster, it's what forces do, it accelerates us here, so there's no longer any acceleration, right? And yesterday we talked about that there's an increase in acceleration between A and B, and then because this is starting to curve here, it's slowing down at between B and C. And then terminal velocity is where there is a flat line or no slope, but we do have 8 kilometer or velocity of 8 meters per second at that flat spot. So it is moving, but it's not accelerating. So that's the difference between forces. Forces need to have some sort of acceleration. Okay, so what I'd like you guys to do today, let's go to the default one here. Okay, is I'm going to do the drawing here in a little bit. I'll probably interrupt you, but I will give you the big blue button link here if you need to talk about anything about your grades, missing assignments, help on assignments, okay, or help, just come into the help assignment there, okay. And also you should be working on oops, that's not what I want to do. Should be working on W8 assignment 1, because that's mostly vocabulary, vocab. Remember, the vocab is in your week 8 module. Okay, tomorrow is the post test. That'll be open only for a day. So if you do that assignment and get 8 out of 10, I will give you a bonus, not a bonus, but I will give you a credit for something. So see me about that. All right, so I will. Okay, so these are the names of the people that were in the quizzes yesterday. Thank you guys for being there. We had about a little less today. So let's see who the winner is for this one. Gavin. Is Gavin here today? Oh, no, no Gavin. Okay, no Gavin. All right, keep going until we find somebody here today. All right. Thanks for saying that, Kylie. DeAndre won. I win, he says. Okay, right. Thanks for playing yesterday for yesterday. So I will take some notes or some information from either the participation in the chats or in the Kahoot for yesterday for tomorrow. So we're getting close to the end of the marking period, so try to get those grades up, ladies and gentlemen. If you need any help, I'm still available.